All right, 13.1 is multiplying and dividing expressions, just like I said, with common basis. First thing you look at are your exponents. Let's make sure we're okay with what they mean. So if I have 2 to the third power, that means 2 times itself 3 times. So this number around here, the regular size number, is your base. And the number up here, your superscript number, is your exponent. So the same thing happens down here. We have 3 to the second power. So 2 to the third power and 3 to the second power, of course, are not the same. 2 to the third power is 2 times itself 3 times. 3 to the second power is 3 times itself 2 times. 2 to the third power will give you 8. 3 times 3 will give you 9. All right, looking at 5 squared, negative 5 squared, and then negative 5 squared with parentheses. Make sure we're okay with the difference. Of course, 5 squared is just 5 times 5, which is a positive 25. With the next two, we have to be careful. When we use parentheses, whatever's inside of the parentheses is being affected by your exponent. So that will be negative 5 times negative 5, which is positive 25. Negative times negative give you positive. Now, if the parentheses are not there, the only thing that's being affected by the exponent is what is right up against the exponent. So that'll be negative, and then 5 times 5, which would be a negative 25. So this negative stays on the outside and is never affected by your exponent. So make sure you're careful with that. If you're trying to ensure that your negative is affected by the exponent, you have to use parentheses. Same thing occurs if I have variables involved. If I have x, y squared versus x times y squared or xy squared, here only the y is squared. And then here both x and y are squared. All right, any questions? All right, so they give us these 4 expressions in the next one. Tell us to evaluate. And they give us a is equal to 2, b is equal to -3. So we just plug in and calculate accordingly. That's 5 times a squared. That's 5 times 2 squared then. As a matter of fact, let me turn this red. Distinguish between our original problem. So that's 5 times 2 squared. Had to square the 2 first. 2 times 2 is 4. And then 5 times 4 is 20. All right, next one, 5 times a squared. So that's 5 times 2 squared. 5 times 2 is 10. Then 10 squared is 100. 10 times 10. Any problems? So the next one, 5ab squared. That's 5 times 2 times -3 squared. That's 5 times 2 times 9. Of course, you have to do the square first. -3 times -3 is positive 9. 5 times 2 is 10 times 9 is 90. Last one, 3 plus a squared, b plus a squared, excuse me. It's -3 plus 2 squared. -3 plus 1 is -1 squared. -1 squared is -1 times -1, which is +1 squared. All right, so they starting to get into our exponent rules. They give us just 2 to start us off with. I think there's about 10 of them that we'll run through, but just 2 to start us off with in this section. Basically, if you have the same base, remember that bottom number or the regular size number is your base. If you have the same base, when you multiply those numbers with the same base or those variables or terms with the same base, you're going to add your exponent. If you divide, then you'll be subtracting your exponents. So directions could just be simplified. All right, so w to the third times w to the fourth is going to add your exponents. So that's w to the seventh. 2 to the 4th times 2 squared. 2 to the 4 plus 2, which is 2 to the 6. Something like 2 to the 6, they would expect you to simplify further just because you can. Now, if you had like 8 to the 6, then they wouldn't expect you to do it because the number's too large. I'm pretty sure if you put the answer in 2 to the 6 in Connect Math, and if they wanted something more simpler, then they would tell you. They wouldn't mark it wrong. They would let you know it can be simplified further. So 2 to the 6 is 64. And the next one, we have y to the 13th times y to the 6th. Don't forget, when you don't see anything, they assume you know there's a 1 there. So that's 13 plus 1 plus 6, which would be y to the 20th. Any problems with that first rule? All right, next one, t to the 6th over t to the 4th. That's, try to stay consistent. That's t to the 6th minus 4, which is t squared. 5 to the 12th divided by 5 to the 10th. 12 minus 10, 5 squared, but 5 squared is 25. All right. By x to the 4th times x to the 5th divided by x cubed. X to the 4th times x to the 5th. Adding our exponents because it's multiplication, and that'll be x to the 9th. X to the 9th, then divided by x cubed, subtract your exponents. That's x to the 6th. Okay, so here we have negative 3p squared, q to the 4th, times 2p q to the 5th. So what we would do is compartmentalize what we can multiply to each other, pretty much multiplying like terms. So what I mean by that, negative 3 times 2 will go together, p squared times p, and then q to the 4th times q to the 5th. Now simplify accordingly. Negative 3 times 2 is negative 6. P squared times p. Once again, there's a 1 here. So that's 2 plus 1, which is 3. And then for q, 4 plus 5, which is 9. All right, one more out of this section before we go to the next rules. Let's see. All right, so 16w to the ninth, y to the third over 4w to the eighth, y. So we handle this the same way we handled the previous problem, where we put together those things that can be simplified. All right, so 16 divided by 4 is 4. W to the ninth over W to the eighth. Subtract those exponents. So that's W to the first. 3 minus 1 for the y's exponent, which would be 2. So before we go to 13.2 questions. All right, so have some more rules. Got the power rule. Let's call this rule number 3. All right, so here's our power rule. We got x to the n raised to the nth power. If you're going to raise a power to another power, you multiply your exponents. Directions just simplify. All right, so s to the fourth power raised to the second power. That's 4 times 2, which is s to the eighth. Ten squared raised to the third power. That's 10 times 3, 10 to the sixth. And so this next one, we have x squared, x to the fifth, raised to the fourth. You simplify what's in the parentheses first. That means we'll add our exponents, because you're multiplying. Whenever you multiply, you add your exponents. So it's x to the seventh raised to the fourth power. Then multiply your exponents, x to the 28th. All right, next two. You have two different bases, in other words, x, y, but you're raising them to that same power. You can distribute that power to each term. So here we have x, y to the nth power. That m goes to each term. So it's x to the m, y to the m. Or x over y raised to the nth power, same thing. That's x to the m over y to the n. The nth power goes to each different base. Okay, here we have 5x squared y to the 7th. I'm going to apply this cube to each piece. So there's 5 cubed, x squared, cubed, y to the 7th, cubed. 5 times itself 3 times, 125. Power to a power, so we're going to multiply these exponents. So it's x to the 6th. Same thing here. 7 times 3 is y to the 21st. All right. Here, 1 over 3x to the 4th. 2 goes to all 4 pieces. So it's going to be 1 squared, 3 squared, x squared, y to the 4th squared. One squared, of course, is 1. 3 squared is 9. X squared is x squared. Y to the 4th squared. Multiply your exponents. Y to the 8th. Questions. Do one more out of this section and then go to the next. So these 3 sections, because we're going to do the next one as well, it's basically you using or getting used to using your exponent rules. Make sure you put them into practice. So here we have 3CD times 2CD cubed. So this cube out here needs to go to one of those. That first 3CD stays the same. Next we have 2 cubed, C cubed, D cubed. That's going to be 8 C cubed, D to the 9th. Now you will put together the pieces that you can simplify. Even if you don't write this, these steps all the way out, this is how you're processing it, or compartmentalizing what's going on. So 3 times 8 is the 24. C times C cubed is C to the 4th. You add your exponents, then D times D to the 9th, D to the 10th. All right, questions before we 3 sections is enough. We'll look at our last section for today. Hold on, let me see what 13.4. I don't know, we'll see. All right, so let's look at 13.3. All right, so definitions of b to the 0 power and b to the negative exponent. So let's see, that last rule was number 5. Yep. So x to the 0 power is equal to 1. So anything to the 0 power is going to be equal to 1. Just have to be careful once again with those parentheses and negatives. Make sure we're okay with what different things mean as we see them. All right, so just say anything to the 0 power is 1. So 4 to the 0 power is 1. Now, this goes back, the next two goes back to what we were saying about an exponent being applied to a number with a negative, using parentheses or not using the parentheses. In this next one, negative 4 to the 0 power without parentheses is negative 1, because that 0 is not applied to the negative. Now, in the second one, when you use parentheses, or third one, I should say, that whole negative 4 is being applied to the 0 power, which will give you 1. For x to the 0 power, the only thing that's being applied to the 0, the only thing that's being affected by the 0 power, there we go, is the x. So that's 4 times 1. So that's 4. Then in the second one, because we're using parentheses, that whole thing is going to go to 1 because it's affected by the 0 power. All right. Questions on anything going to the 0 power? All right. Thank you. All right. So next rule, we're looking at the negative exponent. So I think that was rule 6. Yeah. Let's call this one 7. X to the negative m. Right, m right. 8. All right, so the next three deal with the effects of a negative exponent. So x to the negative m, if I want to write it positive as a positive exponent, I drop it down to the denominator. So if I have a negative exponent in my denominator, I want to make it positive, I raise it up or bring it up to my numerator. Then if I have a whole fraction that's being affected by a negative exponent, I can just flip that fraction and get rid of, or I just say to apply the negative effect. So notice it goes from being negative m to positive m, but my fraction has been flipped. So that negative effect of the exponent flips your fraction. All right, so looking at these three, c to the negative third power to write it without a positive exponent, or write it as a positive exponent, just drop it down to the denominator. 5 to the negative second, drop that down to my denominator, but also 5 squared is 25. So it's 1 over 25. Negative 3 raised to the negative fourth power, those two negatives have nothing to do with each other. So what this negative makes me do is bring that negative 3 to the fourth power down bottom, drop that negative that's applied to the 4. And now, negative 3 times negative 3 times negative 3 would be a positive 81. So once again, those two negatives had nothing to do with each other. So don't apply a negative to a negative, which turns it positive. It's not the case in this scenario. All right, next two. Once again, make sure we are careful with these parentheses. In this first one, the negative 2 is only applied to the y. So I leave my x in the numerator, and that tells me to drop my y to the denominator. The next one, because I have parentheses, I drop both terms to the denominator. And just like before, when there was nothing left in the numerator, you have a 1 up there. And if I want to keep going, that 2 needs to be applied to the x and to the y. Questions? Any questions? All right, now if my negative is in the denominator, if I have 1 over 6 to the negative second power, I bring it up top to turn it positive, and then 6 squared is equal to 36. I didn't turn it, but it's all right. Next one, negative 3 over 5 raised to the negative third power. These have nothing to do with each other. But what this negative does, it tells me to flip that fraction. So negative 3 over 5 becomes negative 5 over 3 raised to the third power. Cube each. So that's negative 5 times itself 3 times. Negative 125. Same thing happens down bottom with 3. So that'll be 27. 3 times itself 3 times. All right, questions? Any questions? A few more in this section will be over. I'll just do that one. All right. So looking at this one, x to the second times x to the negative seventh over x cubed. A couple different ways we can handle this one. One way is to go ahead and add the exponents in the numerator because that's multiplication. So that'll be negative 5. So we have x to the negative 5 over x to the third. Then we can subtract our exponent. So be careful here. Make sure you don't lose a negative. That's negative 5 minus 3. So that division sign says subtract exponents. So negative 5 minus 3, x to the negative 8th. And to simplify it all the way, that will be 1 over x to the 8th. All right, so here we have 2p to the negative 4th q cubed over 5p squared q raised to the negative 2nd power. So what I would do first is flip the fraction because of that negative exponent. Now if we wanted to, well, this is up to us which way we want to go. We can either apply this square to each piece to get it out of the way, or if we want to simplify on the inside, we can do that first. It doesn't matter which way. Like I said, with most of these, there'll be multiple ways that you can take care of the problem. I'll just go ahead and get rid of that square on the complete outside. Just go ahead and square each piece. All right, so I square each one of our separate bases. You just gotta make sure you follow your rules accordingly. 5 squared is just 25. Exponent rule, or the power rule I should say, power to a power means you multiply, so that's p to the 4th. That's just q squared. 2 squared is 4. Multiply your exponents in both cases. P to the negative 8th, q to the 6th. So now, like we did before, here we can put together what can be reduced. So 25 over 4, we can't do anything with it, but you do analyze it as if you could. P to the 4th minus -8. So once again, make sure you're careful with your negatives. Don't lose one. Whenever you divide in like bases, you subtract your exponent. So that's P to the 4 minus -8, and then we have Q squared minus 6 at 2 minus 6 for the exponent. Now that's going to be P to the 12th. You know, negative to a negative turns positive. Plus 4 plus 8. And then Q to the -4th. 2 minus 6. So to finish it off, that'll be 25 P to the 12th over 4Q to the 4th. You know, because it's negative, you know, you bring it down bottom. All right. I got one more. Yep, got one more. All right, questions before we do it? So here we have 2 to the negative first, 3 to the negative first, plus 5 to the 0 power. So that's 1 over 2 plus 1 over 3 plus 1. If we're going to rewrite it without negative exponents and acknowledge the effects of a 0 power. All right, so as a fraction, we know that 1 is 1 over 1. In order to add fractions, don't forget we need an LC, common denominator. That'd be 6, because that's the smallest number that both 2 and 3 can divide into evenly. So that means I want each one of my denominators to be 6. So you say what times 2 will give me 6, and that's 3. Whatever you do to the bottom, you do to the top. What times 3 will give me 6? That's 2. Do the same thing here. And what times 1 will give me 6? And that's 6. And there we go. So that's 3 over 6 plus 2 over 6 plus 6 over 6 will give me a final answer of 11 over 6. All right, questions? Any questions? All right. So that's the first 3 sections out of chapter 13. So got a little time, but that's good enough. I don't think we have to jump into another section today. So, as always, try the stuff out. See if you have any questions. If you do, make sure you get with me so we can do that. Or, as always, you have opportunity to ask those questions during class time. So, if you guys are good and I'm good, you have a good weekend. Not weekend, we just came from the weekend, but have a good day and be safe. And I will see you on Thursday.